Each class starts with a daily summary, and this is just telling you what we're going to do today. So calculus is the study of change. If a change in one thing causes a change in another, calculus is probably lurking behind the scenes. For example, if you toss a pebble into a lake, you create a circle whose radius increases as time passes. Right? And as a result of the increased radius, the area of the circle also increases. So the change in radius causes a change in the area, and calculus will allow us to precisely analyze those kinds of changes. Okay, so here's our little demo. We're going to watch a quick clip of a soccer goal by Wayne Rooney. Okay, so this goal was voted the greatest goal in the 20-year history of the Premier League. In an issue of ESPN, the magazine, it was claimed that at the moment of impact with the ball, the foot of Rooney was rotating at an astounding rate of 2,000 degrees per second. Is 2,000 degrees per second even humanly possible? How come? So think about what it means. It means that in 1 second, he rotated 2,000 degrees, which is how many rotations? Like 6 rotations in a second. So he would be like flipping over, right? So it doesn't seem like he could sustain that speed, right? But could it happen for an instant? Yeah. So sustain it, probably not, but maybe instantaneously. His foot is rotating at 2,000 degrees per second. Yeah. But maybe he could hit that speed in an instant. Okay. How do you think they calculated that number of 2,000 degrees per second? From a fraction of a second. They looked at how many degrees his foot moved in over some amount of time, right? So probably they looked at the film frame by frame, right? And they said in some small fraction of a second, they figured out how far his foot moved, right? It started here and finished here, and that happened in some small fraction of a second. So they looked in change in position of his foot divided by the change in time for some small change in time. Rates of change, and in particular instantaneous rates of change, are the heart of Calculus 1, and we'll be seeing them throughout the semester. Okay, so we're going to take a quick look at this Excel file that deals with plant growth. All right, so I'm going to move this slider so we can watch the plant growing. Okay, do it again. So I'm just holding this down so we can see it grow slowly and then quickly and then slowly again, right? All right, so based on that little animation, we'd like to make a sketch of the height of the plant as a function of time. So maybe we'll watch it one more time, keeping in mind what we want to graph. We want to graph its height as a function of time. So take a minute and just draw a little sketch. I'll play it a couple more times. All right, so it looks to me like it started growing pretty slowly, right? So over time, you know, at the beginning, in some small beginning amount of time, it just is like increasing a little bit. It goes from no height at all to a short little seedling, right? And then it starts to grow kind of fast, right? So let's watch it one more time. Okay, so at first, little seedling, right? It's kind of slow at first, and right about now it starts to really get fast, right? And then as it reaches its full height, it kind of slows down again. Okay, so here it starts to get fast over, sort of a good chunk of time. It gets a big increase in height over that interval of time. Okay, and then over the last little bit of time, it looks like it has kind of a smaller increase in height, right? So from here to here, that vertical distance is not very big, but from here to here, that was a big vertical jump over the time interval. So it kind of has like a S shape, slow, fast, slow. All right, so now we're going to watch it again, and we have, we're going to watch the paper moving, and the paper is going to mark the height as a function of time. Pretty neat, huh? So that's what its height looks like as a function of time. So slow, fast, slow. All right, so let's mark a special point on our graph that represents the moment where the plant is growing the most rapidly. Let's do it on a better graph than the one that I drew. Grab this. All right, so looking at that red graph, we've got time down here, and we've got height of the plant on the y-axis. Where on the graph do we have the fastest growth? In the middle, right before it starts to curve down. Yeah. Yeah. Yep. So at this point, if you were to look at its average speed, right? You could look a little bit to the left and a little bit to the right, and that line would tell you its average speed at that point. And it's a pretty steep line, right? If you compare that to the average speed down here, between any two moments of time, change in height over change in time will give you the rate at which it's changing. That slope is much less steep, right? So this indicates the steepness here indicates the fastest rate of change. And after this moment, it starts to get less steep again, right? You look at little time intervals. So all of the problems that, this special point has a name we'll see formally in a coming class. It's called a point of inflection. That point where it goes from curving upwards to curving downwards, right? It's called the point of inflection. So all the problems we're going to tackle today involve calculus. Among other things, calculus allows us to find extremes, that's maximum and minimum points, on a graph, and it opens the door for us to understand with great precision the behavior of graphs. All right, so we already looked at several highlights from the syllabus. Part of your homework tonight is going to be to read that document more carefully. So now we are at the group activities part of the class. So you're going to start by introducing yourselves to the people you're sitting with, and then you're going to jump into doing some calculus.